Hi guys, welcome to my channel. In this video, I will be covering complete unit 4 in DevOps subject. I will explain each and every topic in detail. And whatever the topics that I am going to cover in this video, I will provide all those topics and the timings in description. Before starting this video, please check in description. Guys, I will provide DevOps unit 4 handwritten notes in description. You can download from description. Guys, I have uploaded complete DevOps subject tutorials. I will provide that link in description. You can watch from there. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. At first I will explain what are build systems. Guys, build system is nothing but it is a software. By using this software, we can compile code and also we can test that code. If compiling and testing is successful, then it will package that code. That is nothing but it will create one executable file. Directly we can place that executable file in server. Placing our executable file in server is known as deployment. So build system is nothing but it is a software that can compile and test code to verify code is working correctly or not, and then it will package that code, that is it will create an executable file for deployment. So build system is nothing but it is a software that will perform three operations. One is compiling code, next one is testing code, and next one is packaging that code. That is nothing but it will create one executable file. Guys, there are many build systems that have been created for software development. And also sometimes you may feel like there are more build systems when compared to programming language. These are some of the example. For example, for Java code, you can use build systems like Maven, Gradle and Ant. For C and C++ code, you can use build system like Make. And for Clojure programming, you can use build systems like Langingen, Boat and Maven. And for JavaScripts, you can use Grunt. For Scala, you can use SBT. For Ruby, you can use Rake tool. And for shell scripting, you can use various kinds of build systems based on your needs. Guys, all these are build systems. That is nothing but all these are softwares. By using these softwares, we can compile code, we can test code, and as well as we can package that code. That is nothing but we can create one executable file. By using all these build systems, we can perform these operations. Depending on your company and type of software that you are creating, you need to choose softwares. And some companies are creating their own build softwares. Normally, many companies will use only one build system for all projects, but it is not right because, for example, let us say one company is using Maven software for all projects, but it is not right because Maven is suitable only for Java projects. It is not suitable for Ruby projects and JavaScript projects. For JavaScript, Grunt software will be best, and for Ruby, Rake software will be best. So, based on your project, you can choose different build systems. You should not depend only on one build system. As a developer, whenever you write code, at first you need to build that code in your own system. If build process is successful in your system, then you can place that code in GitHub. So all remaining employees can access that code. So as a developer, at first you need to build code in your own system. For example, let us say you are a developer, you are developing one project. That project contains code related to Java and as well as JavaScript. So now you need to build both Java code and as well as JavaScript code. In order to build Java code, you need to use Maven, and in order to build JavaScript, you need to use Grunt. So now what we can do is, now we can combine these two softwares and you can use in order to build your project. Combining these two softwares makes your work easy. So if you have to support multiple build systems, you can combine them. This makes things simpler and allows different build systems to work together. For example, one company wants to build a Java project. Then in their system, they need to run this command in order to build Java project, mvn clean install, where mvn stands for Maven. Whenever you run this command, at first it will compile Java code, and then it will test Java code, and then it will save executable file in your system. Next I will explain what is Jenkins build server. Guys, build system is nothing but it is a software, and whereas build server means it is a computer, that is it is a system. If you want to build any project, then you need to install build system software in your build server. So build server is a machine, that is it is a computer that runs the build process automatically. Build server uses the build system software to compile code, to test code, and as well as to create executable files. So one of the popular build server is Jenkins, and this Jenkins is written in Java. As in olden days before Jenkins, companies used one server called Hudson. Oracle company took this Hudson. In that company, there is one creator called Koshuk Kawaguchi. This person modified Hudson server and then he gave new name. That new name is Jenkins. So this Jenkins server is updated version of Hudson server, and today Jenkins is more popular than Hudson. Jenkins is famous for building Java projects. Guys, not only Java projects, you can also build softwares made by other programming languages. Guys, installing Jenkins server in your system is very easy. For example, let us say I am using Ubuntu operating system. Then you need to run this command in order to install Jenkins. That is sudo apt-get install Jenkins. Whenever you run this command in your system, you can install Jenkins. And in order to start Jenkins service, you need to run this command sudo systemctl start Jenkins. Whenever you run this command, it will start Jenkins. And in order to access Jenkins, you need to open your web browser and you need to type this URL. That is http://localhost:8080. You can access Jenkins in this URL. And in order to see status of Jenkins, that is, in order to check whether Jenkins is active or not, you need to run this command sudo systemctl status Jenkins. Whenever you run this command, you can see status of Jenkins. In Jenkins, work is organized into jobs. Jobs can perform various tasks like compiling code, testing code, and deploying application and so on. Guys, in Jenkins, we don't call work as task. We call work as job. For example, let us say I want to compile code and I want to test that code. So we call it as job. Guys, in Jenkins, we can automatically compile code, test code, and we can deploy code. I will give an example. Let us say I am developer. I developed a project and then I will place that project in GitHub. Now what I will do is, I will connect this GitHub website with Jenkins. So whenever any developer places code in GitHub, automatically Jenkins will take that code. Then Jenkins will automatically compile code, test that code, and then automatically Jenkins will place that code in server. So in Jenkins, we can automate jobs. For example, let us say there is another developer. He modified my project. Whenever he modified my project, automatically again this code is compiled, this code is tested, and this code is placed in server. Jenkins is especially used for continuous integration and continuous delivery pipelines. It ensures the software is quality and efficient. Guys, continuous integration is nothing but compiling code, testing code, and then creating one executable file is known as continuous integration. And continuous deployment is nothing but placing our executable code in server is known as continuous deployment. So this entire pipeline is created by using Jenkins. Next topic is Jenkins plugins. Guys, there are so many plugins that you can install in this Jenkins server. Directly you need to open this Jenkins website and then you can install all plugins in that website. And some plugins can be installed even without restarting Jenkins. And one of the popular plugin is Git plugin. So from Git, Jenkins will automatically pull that code and then it will perform various operations like compiling code, testing code, etc. Among other plugins, we need the Git plugin to pull our source code. Guys, these are some of the popular plugins that you can install in your Jenkins server. First one is Git plugin. By using this plugin, you can pull code. And next one is Maven plugin. By using this Maven plugin, you can build Java projects. And next one is JUnit plugin. By using this JUnit plugin, you can perform unit test. And next one is Selenium plugin. By using this Selenium plugin, you can perform integration test. And next one is Docker plugin. By using this Docker plugin, you can place your application in containers. These are some of the popular plugins that you can install in Jenkins server. Next topic is managing build dependencies. Guys, whenever you develop any project, he cannot directly build and run that project. Before that, whenever any developer develops project, along with this project, he need to add some more files in that project in order to build and run that project. We call these files as dependencies. Only if dependencies are present, then we can successfully build and run that project, or else we cannot build and run that project. Build dependencies in simple terms refer to the other software components or files that your application needs in order to successfully build and run your application. Some build systems like Maven for Java and Grunt for JavaScript automatically create dependencies like POM XML file based on your projects. Guys, some build systems like Maven and as well as Grunt. These both softwares can automatically create dependencies based on your project. And for example, for C and C++ projects, there are some tools like GNU Auto Tools and Auto Config Tools. What these tools will do is, instead of separately creating dependencies, already some dependencies are present in these tools. So these dependencies are automatically added to C and C++ projects. Whereas Maven tool will create dependencies based on project, And whereas GNU auto tools and auto config tools, these tools already contain some dependencies. These dependencies are automatically added to all projects. Guys, in software development, whenever you want to develop any software, then you need to have clear idea about features of the software. For example, let us say I want college application. Then you need to know all features of that application, like in that college application there must be student login form, faculty login form, student attendance, faculty attendance, and so on. So whenever you develop any project, you need to know all features of that project. After placing your software in server, if you miss any feature, then it will be very tough to modify entire code again. Guys, for example, let us say I am developing project, but I don't know what are the dependencies that are required for that project. So if you don't know dependencies required for your project, then you can use some tools like RPM, where RPM stands for Red Hat Package Manager. Whenever you upload your project into RPM, RPM will automatically provide what are the dependencies that are required for your project. Based on that, you can create dependencies. Next, I will explain what is file system layout. In DevOps, the file system layout refers to how files and directories are organized on servers or systems and managed within DevOps environment. Guys, file system layout is nothing but how files and directories are organized on servers. Directories are nothing but folders. In order to successfully build and deploy our software, definitely we need to arrange all files and folders in proper format. So arranging files and folders in proper format is known as file system layout. This includes, first one is application deployment structure. Guys, in server, we need to arrange our application and the dependencies in proper organized format in order to deploy our application. If you don't arrange your application and dependencies in proper format, then we cannot successfully deploy our application. Second one is configuration management. Guys, there are some configuration files like YAML file, JSON file, etc. By using these files, we can configure our server. So we need to arrange these files in proper format. And third one is version control. Version control is nothing but Git. In Git software, we need to store our code files in organized format. And fourth one is artifact repositories. Guys, whenever you develop any software, then we need to build and test that software. So after building and testing is successful, then artifact will be generated. So we need to store these files in organized format in repositories. Guys, if you follow proper file system layout, then it is very easy to develop, test and deploy your software. Next topic is the host server. Guys, duty of build server is to create software. So after creating your software successfully, we need to place that software in host server. So whenever you place your software on host server, all users can access the software. So duty of build server is to create software, and whereas host server focus on running the software. So once application is placed in host server, all users can access that application. So in any company, build server is very important. While building software, build server will consume lot of processing power, memory and disk space. That is why whenever you purchase any build server, you need to purchase only high quality build servers that has high disk space and RAM. Different employees will write code and they will place that code in build server. So definitely build server must be fast. As we know, machines are cheaper than people. That is why we need to invest your money on good machines. Next topic is build slaves. Jenkins is one of the popular build server. Jenkins will build code. And in order to complete build process very fast, we can connect Jenkins server with other servers. We call these servers as build slaves. Different slaves contain different operating systems. So based on needs, Jenkins server will send tasks to any of these servers. Guys, we can connect your slaves with Jenkins by using three ways. First one is by using SSH, and second way is you need to install Jenkins software in your build slave. Next way to connect your build slave with Jenkins server is by installing Java client in your build slave. These are three ways by which you can connect your build slave with Jenkins server. To make build process faster in Jenkins, you can add extra servers called build slaves. The main server sends tasks to the slaves either in a round robin way or based on specific needs. Guys, Jenkins server will send a task in round robin way like it first to this server, next to this server, next to this server, and again first server, second server and so on. For example, Jenkins server want to perform task on Windows computer. At that time, directly Jenkins server will send task to slave 2. So task is shared either in round robin way or based on specific needs. So some tasks need only particular operating system. So having different build slaves is very important. You need to launch some task only on Linux operating system. At the time we cannot use Mac operating system or Windows operating system. Guys, you can run various tasks on different build slaves at a time. Guys, for example, let us say you are developing an Apple project. Now you need to build an Apple project. But by using virtual server, we cannot build Apple projects. At that time, directly you can use Mac slave in order to build Mac projects. So based on your project, Jenkins server will send project to different build slaves in order to build your project. There are several ways to connect build slaves to master. One common method is using SSH or by using Jenkins software, and another method is by downloading Java client in your slave. If slave don't support SSH, then directly you can use Java client. Guys, sometimes you can also use Linux servers in order to build software related to Windows. At that time, you need to install cross compilers in your Linux operating system like GCC with MinGW. Whenever you install this in your Linux server, you can easily build Windows softwares in Linux server. Guys, companies like telecom and banks use system code. By using this system code, you can build various kinds of application in only one server without using different kinds of servers. Guys, each and every company has different needs and you need to set up your environment based on that needs. Next topic is software on the host. Guys, if you want to build any software, then you need to install various kinds of tools in your build server. As we know, Jenkins is one of the popular build server. But actually Jenkins server will not perform any build operations. In Jenkins server, there are various built-in tools. These tools will perform build process. Guys, whenever you are using any build server, definitely we need to install Linux operating system in that server. And by using internet, you can install various kinds of tools in that server. And whatever steps you follow to update application server, same steps you need to follow in order to update build server. Next I will explain what are triggers. Guys, trigger is like a start button that begins an action automatically based on certain conditions or events. For example, I clicked on mouse, so some action will take place. I clicked enter button on my keyboard, so some action will take place. So clicking on mouse, clicking on keyboard, all these are examples of triggers. At first I will explain what are scheduled builds. Guys, whenever you develop any code, at first we need to compile that code and then we need to test that code. After testing is successful, then one artifact will be generated. So compiling code, testing code, and as well as generating artifact. All this comes under build process. Guys, for example, let us say, every day at morning 6 o'clock, I need to perform build process on my server. This is example of scheduled builds. You can set a timer to run builds at specific time, like every hour, every day. This ensures builds happen regularly. Next one is polling for changes. Guys, whenever any developer write code, at first he will place that code in Git software. From Git, he will place that code in GitHub. So whenever developer places code in GitHub, automatically Jenkins server will start build process. For example, another developer modified code in GitHub. So whenever any developer modify code in GitHub, automatically Jenkins server will start build process. So Jenkins can check your code repository like Git for updates. If changes are found, then Jenkins will start build process automatically. So only latest code will be in server. And third one is nightly builds. Guys, normally for some kind of projects, if you start build process at morning, it will take lot of time to complete that build process. So in order to save your time, you can start build process at night time, so that it will save your time. So night builds are scheduled builds that runs at night, usually when no one is actively working. These night builds take lot of time, so employees can check it in next working day. And fourth one is upstream and downstream builds. Guys, normally in Jenkins server, we will perform different kinds of jobs one after another. For example, let us say, total I want to perform 4 jobs on my Jenkins server. First job is to check code, next job is to build code, next job is to test code, and next job is to deploy code. So one job is connected to another job. Whenever one job is successful, then automatically Jenkins server will start next job. For example, I am unable to complete job 2. So whenever any job is unsuccessful, then it will not go to next jobs. When one job finishes successfully, it can trigger to another job. For example, job 1 is completed successfully. Then we call this job 1 as upstream. Now it will perform second job. So we call this second job as downstream. So in Jenkins, by using triggers, we can automate build process. So that by using triggers, your software is built and tested successfully. Next topic is job changing and build pipelines. Guys, in Jenkins, job chaining is nothing but connecting jobs. So that whenever one job finishes successfully, then automatically it will start next job. So one job depends on another job, like job 2 depends on job 1, job 3 depends on job 2. Similarly, job 4 depends on job 3. For example, I am unable to complete job 2. So if job 2 is unsuccessful, then it will not go to job 3. I completed job 1. So we call this job 1 as upstream. Now it will go to job 2. So we call this job 2 as downstream. The first job in the sequence is called upstream build and next one is called downstream build. Guys, by using job chaining, we can complete multiple tasks. And there is also complex job chaining. We call this complex job chaining as pipelines. In Jenkins server, there is one plugin called workflow. By using this workflow plugin, we can create advanced pipelines. And we can create these pipelines by using scripting language called Groovy. And by using these pipelines, we can see each and every step clearly. And by seeing each and every step clearly, you can clearly understand how work is going on. Guys, whenever any developer create project, he will place that project in GitHub. Along with this project, he will create one Jenkins file. And this Jenkins file is written by using Groovy script. A written script. That script contains total 4 stages. One is build stage, next one is test stage, and third stage is downloading artifact, and stage 4 is placing that artifact in server. So I created Jenkins file in order to perform these 4 stages, and this code is written by using Groovy script. Now what I will do is, I will connect this GitHub with Jenkins server. So immediately whenever I place project, automatically Jenkins will perform these 4 operations. And clearly you can see each stage, whether it is successful or not. For example, let us say testing is unsuccessful, then automatically it will stop here. So job chaining is nothing but connecting multiple jobs. So only if one job is successful, then it will go to next job. So if all stages are successful, then my build process is successful. Next I will explain what are build servers and infrastructure as a code. Guys, in DevOps, even if you want to configure your server and if you want to manage your server, even for that operations you need to write code. So in order to create softwares you need to write code, and similarly in order to manage and configure your servers you need to write code. So when we talk about DevOps, you can manage our servers and setups using code, same like writing code to create software. Guys, there are some problems with Jenkins server, and that first one is Jenkins interface. Guys, if you want to perform any operation in Jenkins server, you can perform operations in 2 ways. First one is by writing script, or else you can also use web interfaces in order to perform operations. There is one advantage of using web interface, that is, there is no need of having any programming knowledge. But this web interface will not provide complete features. If you want to use Jenkins server perfectly, if you want to utilize all features of Jenkins server, then definitely you must have coding knowledge. Jenkins uses code files to set up tasks, but most people use Jenkins web interface to make changes. One good side of using web interface is there is no need of having any programming knowledge. And one bad side is if you use web interface, you cannot utilize complete features of Jenkins server. Guys, for example, let us say I written code in order to set up my server for particular project. So next time when you are developing another project, you can utilize code which is written before. But if you use web interface, you cannot perform code reusability. You need to perform each and every step again. So this is one of the main drawback of Jenkins server. Instead of using Jenkins, you can also use GitLab. Even by using GitLab, we can perform build process. Whereas in Jenkins, you need to write complete code. But whereas in GitLab, there is no need of writing code. Already some predefined code files are present in GitLab. Directly you can use that code files in order to perform build operation. So if you don't want to use all features of Jenkins, then directly you can use GitLab. GitLab is very simple and friendly to use. And last topic is building by dependency order. When building software, some parts need to be built before other parts because they depend on each other. And you can do it by using various building tools. I'll give an example. Let us say total there are 3 files. One is file A, next one is file B, and next one is file C. For example, let us say this file A depends on file B and file C. So at that time, at first you need to build this B and C. So only after building file B and file C, you need to go to file A. Because this A depends on B and C. At first you need to compile file B and next you need to compile file C. And by using make tool, you can set this order. You can set order like which file need to be built first. For example, by using make tool, I will set order like at first I need to build file B, next file C. After building file B and file C, I need to build file A. And even by using tools like Maven and Gradle, you can set build order. Maven uses one build graph. That graph name is reactor. By using this reactor, Maven will manage order. And even Gradle also use build graph in order to set up order. Even in Jenkins server, you can install reactor plugin. and the Jenkins server will show build order for Maven projects. For example, let us say your project contains two parts of code. For example, let us say one is part A and next one is part B. So at first you need to compile part A and next you need to compile part B. After compiling part A and part B, you need to combine these both codes and again you need to perform testing on that code. After testing is successful, artifact will be generated. So directly you can place this artifact in server. Next I will explain what are build phases. Guys, Maven is build tool. By using this tool we can perform three basic operations. They are, first one is building. Building is nothing but compiling code. Next one is testing. Testing is performed on code in order to catch various kinds of errors. And third phase is deployment phase. After successfully compiling and testing code, we need to place that code in server. So placing our code in server is known as deployment. So Maven tool will perform these three basic operations. Guys, whatever project you take, definitely we need to perform these three operations. Guys, let us say for example I am developing one project. For example, I want to skip this test phase. Just I want to perform only build and deployment. But you cannot do that because these three phases are mandatory in Maven. In Maven, whatever project you take, definitely you need to follow these three basic operations. And each and every operation is performed in step-by-step manner. Maven is a build tool that makes sure everyone follows same steps when building software. This is helpful for big companies because they don't need to create their own rules for building projects. Guys, whatever project you take, you need to follow three rules in Maven. First one is building, next one is testing, and next one is deployment. So there is no need for companies to create separate rules. Maven very strictly follows order of steps like building, testing, and deployment, whereas other tools like and give more freedom, but it can lead to disorganized build. Guys, for example, if you consider Maven, Maven strictly follows three steps. They are building, testing, and deployment. Whereas if you consider tool like Ant, in Ant we can skip testing. It will not follow rules strictly. If you skip any of these steps, then software quality will decrease. These are three phases in Maven. They are building, testing, and deployment. Guys, Maven will follow order strictly, whereas other tools may skip some steps. If you want to produce high quality software, then testing is very important. A good CI server will catch errors by running automate test. Maven strictly follows all the steps without skipping any of the steps like testing. Next topic is alternative build servers. Guys, Jenkins server is popular build server in order to perform building and testing of software. Guys, not only Jenkins server, there are some other servers available. They are, first one is Travis CI server. This server is popular for open source projects. And next one is BuildBot server. This server is built by using Python programming. And next one is Go server, developed by ThoughtWorks company. And next one is Bamboo server, offered by Atlassian company. And next one is GitLab. This GitLab also contains build server features. Not only these five, there are so many servers available. Based on your company and based on your need, you can select server. Next topic is collating quality measures. Guys, collating means collecting. We need to collect quality measures. By following these quality measures, we can successfully build software. A build server can help track and improve software quality by providing testing results. As we know, build server will perform testing and then it will provide testing results. Jenkins can run Java unit test and show results directly on the job page. Guys, by using Jenkins, we can test Java projects. After testing, the results are directly displayed in Jenkins page. And not only Jenkins, there are some other tools like Sonar. This Sonar is a tool that provides detailed code quality report. Guys, Sonar will perform testing during build process and then it will display that results on Sonar server. So developers can see detailed report and based on that they can perform improvements on code. Guys, but there is one problem. Whenever you perform Sonar test, then your server will become slow. So it is suggested to perform testing in Sonar server during night time. So using tools like Jenkins and Sonar can help monitoring and improves code quality, but it is suggested to run Sonar at night time or else your build process will become slow.